have a little organizer, graphic organizer up here, just talking about all the different types of numbers. So it'll kind of show you guys where we're headed today as far as the complex numbers are concerned. So as far as complex numbers, we have real numbers and we have imaginary numbers. You guys, everything you have done up to this point in your mathematic career have been working with real numbers. So all your real numbers would be rational numbers, integers, whole numbers, natural numbers, and then you have irrational numbers, which would be numbers like pi or the square root of 3. So they're numbers, but they don't have like an ending decimal value. So those would be your irrational numbers. Rational numbers are anything you can put as a ratio, 1/2, 5/7. Those would be rational numbers. Okay, integers are your positives and negatives. Whole numbers, obviously no decimals, no fractions. Natural numbers are 0 to infinity, so just your positives. Whole numbers would just not, whole numbers don't include, so whole numbers include 0, natural numbers do not. There we go. All right, what we are doing today is we're jumping over here to the imaginary numbers. So there was an issue with there being some numbers that were not defined, and so at one point, mathematicians decided to develop the system of imaginary numbers. So this little guy right over here is the big idea for today. The fact that I is equal to the square root of -1. That is the main concept for our lesson today. So anytime you end up with a -1 under the square root, we're going to change it into an I in order to be able to finish simplifying down the square root, which is kind of what we worked on last class, the simplifying square root stuff. We worked on that last time, and so now we're going to kind of extend that just one more step. Okay, so down here, the core concepts for today, the square root of a negative number. There's two properties that we're going to look at. One says if R is a positive real number, then the square root of -r is equal to I times the square root of r. Okay, basically all I did there was take the negative out from under the square root symbol and make it an I outside the root. Okay, a numeric example, the square root of -3 would be equivalent to I times the square root of 3. The negative comes out and turns into an imaginary. And then the other property that goes along with that, I'm not even going to worry about the in words part. Basically, it's that I squared is equal to a -1. That's the other property you guys need to know. So I guess we can say because I equals the square root of -1, I squared will just equal -1. Okay, if you take a look at this equation for me real fast, the I is equal to the square root of -1. If I take the square of both sides, if I square here and I square here, what we worked on last time is that a square and a square root would cancel each other out. So these guys would cancel each other out, and I'd have I squared is equal to -1. So that's why I squared is equal to a -1. So again, one basic concept, but we're going to extend it to two pieces. The fact that I is equal to the square root of -1. So then I squared is equal to -1. So you need to know this guy and this one that I have highlighted up here. Okay, over here, the imaginary unit is I, and it's equal to the square root of -1. Again, we just talked about that a second ago. A complex number, an example of a complex number, I don't want it to look like a negative. Actually, I should change this one as well so it doesn't look like a negative. Sorry about that. So the imaginary unit is I, which is equal to a -1. A complex number, an example of a complex number could be 2 plus 3i. This is a real number. This is an imaginary number. So what you have now is a combination of a real number and an imaginary number, and that's what makes up a complex number. Okay, we're not going to get into those too terribly much with this lesson, but have a little bit to do with it. So just kind of as you have that idea of a complex number, of what a complex number is. All right, so a few different examples down here, and these should look similar to what we worked on last time. The difference is going to be these have negatives underneath them. So we're going to simplify them down the same way that we did with just our regular square roots, but now we're going to recognize that we have a -1 under the square root, and we're going to turn that into our imaginary. So with our square root of 49, we simplified the square root of 49 down. It would be -1 times 49. That's the first part that I want to do as far as breaking it down. Okay, -1 is prime, so I'm going to bring it straight down. And then 49 would be 7 times 7. So what I have now is the square root of -1 times 7 times 7. Because I'm doing a square root, what I'm going to be looking for is pairs of something. Okay, sorry, Isabella, I'll slow it down a little bit. I know y'all are having to write more than I am. Okay, do I need to scroll back up or zoom out? Do y'all need to see anything? There's all the stuff at the top that we've done so far. Okay. Am I okay to go on now? Are you guys good? All right, so I'm going to zoom it back in, and we're taking a look at this guy right here. So again, the square root of -49 is the same thing as -1 times 49, which is -1 times 7 times 7. Okay, so all of this is under a square root, and because it's a square root, we're looking for two of things. We're looking for buddies. So everybody's in the house playing by themselves, playing together right now, and what we want to do is if you want to go out of the house, you have to have a buddy. So our 7s have a buddy. They get to come out of the house as a 7. Now, little -1, this is like Castor, okay? He doesn't have to have a buddy. This is your imaginary friend. So anytime you have a -1 under the square root, he comes out of the house, but he turns into an imaginary. So nobody can see him. That's why he comes out of the house by himself. Okay, did that concept make sense okay? All right, I'm going to scroll down and go ahead and do number 4 since I'm here. All right, so same thing with the -100. Oh, by the way, up here, since everything came out of the house goes away. All right, nothing was left under the square root, so the square root symbol goes away. That's why my answer over here does not have a square root in it. The square root went away. So same concept down here. It's going to be -1 times 100. Okay, I can bring the -1 straight down. 100 I know is 10 times 10. Again, bring the -1 straight down. 10 we know is 2 times 5. 10 we know is 2 times 5. I know I'm finished with my factor tree when all of the pieces at the bottom are prime. So all of those values are prime. Everything is under the square root like this. And again, we're looking for buddies. Who has a buddy? So we have a pair of 2s. So we can write the 2 on the outside. But there was already a 2 on the outside. So actually the 2 that was -2 that was already on the outside is going to be multiplied by the 2 that we just brought out. Again, -2 was here. You know what, let's do it like this. This may be easier for you guys to follow. So I'm going to go ahead and write my square root symbol in here like this. We're going to go ahead and put the -2 on the outside. We just found a buddy. The 2s have a buddy, so I'm going to go ahead and put another 2 out here, and everything that gets out here is going to have to get multiplied together. Okay, we have 5s that are buddies, so we're going to bring a 5 out. And then we have little -1, and remember -1's Castor the ghost, he's the imaginary, so it's going to come out as the I, the imaginary. Nothing left under the root, so the root is going to go away. Everything that was outside of the root all gets multiplied together. So what is 5 times 2 times -2? So that should give me -20. and then we multiply it by the I, and the I pretty much behaves like a variable. It gets multiplied, divided, added, subtracted, just like variables would. Okay, still doing okay? Is that making sense?
Yes.
Thank you. All right, let's see. So I didn't intend to do all of these. We'll just do a couple more to make sure you guys kind of get the concept down. So if we take a look at this one here, you could look at that as the square root of -1 times 4. So for those of you guys that are kind of catching on, you don't necessarily have to do the whole factor tree. What is the square root of -1? All right, we know that's our imaginary term I. And what is the square root of 4? We know that is 2. So the square root of -4 would simplify down to 2i. All right, so that's just an example of doing it without a factor tree. If you recognize that 4 is a perfect square, you could just see it as -1 times 4. Okay. So the concept could be the same down here. Number 6, and then we would have the square root of -1 times 121. Now, some of you guys may recognize that 121 is a perfect square. We would just bring the 6 straight down. I know -1 is going to come out of the house as the imaginary, as I. And then the square root of 121, that is a perfect square, it would be 11. So now we have 6i times 11, which would be 66i. I'm going to scoot over here and try one more. So 75 is not a perfect square, so I'm going to go ahead and do the factor tree on this one. So I'm going to bring the -1 straight down. 75 is 25 times 3. And bring the -1 straight down one more time. 25 we know is 5 times 5, and then 3 is prime, so we're going to bring it straight down. So we have the square root of -1 times 5 times 5 times 3. And then we already had a 5 in front, so we're going to rewrite that 5 in front. Looking for buddies. So I have a pair of 5s, 2 5s, so I can bring a 5 out. And remember, anything that's outside gets multiplied together once to finish our answer. On the inside, -1 doesn't have a buddy, but remember, he's our imaginary, he's our Castor. So I'm going to go ahead and bring an I on the outside as well. All right, 3 does not have a buddy. He is not allowed to go outside because he's not the -1, so he's not imaginary. He doesn't have a buddy. He's got to stay in. So 3 is going to stay in the house or in the root. On the outside, I have I times 5 times 5. So 5 times 5 would give me 25. And then we have our I on there. And then inside the root or in the house, we would have a 3 left over. I'm going to pause for a second. Did that make sense? Okay. Okay. I'm going to head on to our next page. Okay, so all of these problems work identically to, Is that a word? Sounds weird. Just to, if I gave you guys just normal variables. So I'm going to zoom back in a little bit. All of these are saying is just to simplify the expression. So if I gave you the expression -8 plus 3x plus minus 2x. Okay, that should look pretty familiar. Most of you guys have been doing that since Algebra 1. What we're looking for in a case like that, because we're adding, is we're just going to combine our like terms. Okay, so I would take the -8 and the -1 because those are both constants. Those are like terms. We would add them together and get -9. And then I have a 3x and a -2x. Those are also like terms. Let's do this in a different color. So 3x and -2x, and those would add together to give me x. Okay, your imaginary complex numbers work the exact same way. So I'm going to erase this so that we can do the complex number form. So like terms, -8 -1, those are like, so we would add them together and get -9. Then we have 3i and -2i. Those would add together to give me 1i, or just I. So your final answer for that would be -9 plus I. Okay, does that concept make sense okay? All you're doing is combining like terms for each one of those. So down here, same thing, you find your like terms, add them together. Over here, we're gonna subtract. So I would say when you're subtracting, you wanna distribute the negative in to both of the terms before you combine your like terms. So now we have 36 minus 3i. And now it's -12 minus 24i. And you don't necessarily have to keep the parentheses on there. The parentheses are kind of grouping the complex numbers together. But after you distribute your negative, really those complex numbers can kind of move so that you have your like terms together. So again, we have 36 and -12. So 36 minus 12 would give me 24. And then you have -3i, -24i. So that would mean -27i. Now notice I've written on both of these answers, the real number has come first, and then the imaginary number comes next. So your form should be A plus BI each time you write these answers. Again, this is the real number. This is the imaginary number. Okay, so it's kind of like proper English. That's the order that you want to put them in for it to be proper math. Okay, I'm going to hop down here and I'm going to go ahead and do number 13, and then I'm going to give you guys a second to do number 11, number 12, and number 14 on your own. So again, same concept here. We have two binomials. It's just the binomials have i's instead of x's, but they're going to multiply together the same way that if these were just x's. So if you know FOIL, you can always do FOIL on these. I don't go back to FOIL very often because FOIL only works on a binomial times a binomial. So if I'm going to teach you guys something, I would teach you guys to use a multiplication table or a box. This is what we were using when we were factoring. We're just going to use it in reverse. So what I'd like for you guys to do, we'll do the first one together. Actually, we'll do the second one together because that'll give you guys an example with the imaginary. But we're matching the equations with one of the solutions of those equations. So for example, on x squared, we would want x squared to be isolated or by itself. So I'm going to subtract that 1 over to the other side. So x squared would equal a -1. And then what we worked on last class is once the x squared is isolated or by itself on one side of the equation, we're going to take the square root on both sides. On the left side, my square and square root cancel each other out, and I'm just left with x. On the right side, because I took the square root of a variable, I have to put plus or minus in front of my answer. And then the square root of -1 is the new information we learned today. We know that the square root of -1 is equivalent to I. So your answer in this case would be x equals +I and x equals -I. If you'll notice down here, it only gave you the positive solutions. So for this one, our solution would be A. So capital A is going to go with lowercase b. So for this one, we have x squared. We would add the 4 over. We'd end up with 4. So then we would take the square root on both sides. So now x equals, we put our plus minus, and the square root of 4 is 2. So this one would match with F. Just a regular 2, no imaginary terms on that one. But then if you'll notice on D, when we take that 4 and move it over, we end up with a -4. Again, square root on both sides. And this time when we do our square root, we will end up with the imaginary. So we have plus minus. The square root of that negative, remember that's a -1, so that would be our I. And the square root of 4 is 2. So 2I is the one that would match that one. So D goes with D. Okay, concept's the same for E, so x squared would equal 9. We would take the square root on both sides. X would equal plus and minus 3. The positive 3 is the only one they included down there. Over here, x squared, we would add the 1 over, so x squared would equal 1. Square root on both sides, x equals plus and minus 1, which would be E. And lastly here, x squared would equal -9. Square root on both sides, x would equal plus or minus. The square root of a negative is I. The square root of 9 is 3. So that's how we would end up with B on that one. All right. That, again, is the main reason why we're going through and doing our imaginary and complex numbers right now, is so that you guys can actually finish solving quadratics that have imaginary solutions, just like these guys right here. What questions do I have on these problems before I move on? So then our last page of notes, we just have, let's see, 4, 1, 2, 3, 3. We have 3 equations. So these are just solving quadratic equations. And so you guys actually have 2 methods for solving quadratics. When it's solve a quadratic. Wait, so what we worked on last class, if we're looking to solve, we're trying to figure out what x equals. By the time I'm done, I should know what x equals. Okay, so these would be great review from what we did back in 4.1. Also good preparation for your test that is on Wednesday. So in order to solve the equation, we need to figure out which method we want to use. Do we want to use factoring? Or do we want to use square roots? And it's really going to depend on if you are given more than one variable in the equation, more than one type of variable in the equation, or if you're just given an x squared in the equation. So factoring I would usually use when there is standard form, or if you can move it into standard form. So that's your ax squared plus bx plus c. Your square roots I would use if there is only an x squared in the function, and also when it's vertex form. That's your ax minus h squared plus k form. So if we take a look over here for number 15, there's only an x squared in my equation. So I'm going to do this one by square roots, option number 2, because there's only an x squared. So in order to solve by square roots, I have to isolate the x squared, which means I need to get rid of the 25 first. So I'm going to subtract that 25 over to the other side. Again, we're trying to get the x squared by itself. So now I have negative 25 is equal to 5x squared. Again, I'm trying to isolate the squared term, and in this case, the only thing that's being squared is the x. The 5 is not being squared, or it would have to be written like this. So recognize here that the only thing that's being squared is the x, not the 5. If the 5 was being squared, it would again have to be written like that. So because the x is the only thing being squared, I'm going to divide by 5 on both sides to get this x squared by itself. So negative 25 divided by 5 is negative 5. And then 5x squared divided by 5 would give me x squared. From there, I now have my x squared by itself. So I'm going to take the square root on both sides. The square and the square root on the right side do cancel each other out, and I'm left with x, and I usually put that on the left, not that it matters, but the x is the only thing that's left. I'm going to write it on the left since that's my solution now. And then because I took the square root of a variable, we've got to use that plus minus in front. So plus or minus the square root of negative 5. And now I just need to simplify that square root of negative 5 down. So x would equal plus minus. We know the negative under the square root. This would be the same thing as negative 1 times 5. And we know the square root of negative 1 is I. And 5 is a prime number, so it cannot be the square root cannot be taken or simplified. We would just leave it as the square root of 5. Right, it's not a pretty solution, but it's still a solution. And those actually our two solutions, positive I square root of 5, negative I square root of 5. All right, number 16, same concept. And again, I only see an x squared term. So again, I'm going to do square roots on this one. So again, option number 2 for this problem. You're still trying to get the x squared by itself. So in this case, we would want to add 10 on both sides to get the x squared isolated. So now x squared would equal negative 18 plus 10 would give me a negative 8. The squared is now isolated, so we're going to take the square root on both sides. On the left, my square and square root cancel out, so I'm left with just x. We put plus or minus, and then it is the square root of negative 1 times 8, and I'm going to break that down just a little bit farther. Okay, so negative 1 times 8 would also be negative 1 times, we know 8 is 4 times 2, but 4 is 2 times 2. So I'm going to write this as 2 times 2 times 2. So negative 1 times 2 times 2 times 2 is equal to negative 8. And we're looking for buddies under our square root. So in this case, I have a pair of 2's. So I would write my answer as x equals plus or minus. We have that pair of 2's, so it comes out as a 2. No other buddies, but I do see my Castor, my negative 1 here. So it comes out as your imaginary friend outside. There is a 2 left over under the root, so he has to stay in the house to play by himself. So that would be your final answer for that one. Last example problem, and this one's probably a little bit icky, maybe a little bit mean, but I know we can work through it. You guys will be just fine. So I'm actually going to write it over here to give myself a little extra room. Equals 1/5 plus 4/3 x squared. Okay. So for this problem, I can also solve it by square roots because all I have are squareds. X squareds is all I have in my equation. I do, however, want to put those x squareds together. So I think the first thing that I would like to do is go ahead and take this 4/3 x and subtract it over, 4/3 x squared, sorry, subtract it over to the other side. So it gets rid of them over here and combines some like terms over here. So a -1/3 and a -4/3 would give me a -5/3. And now we have x squared is equal to 1/5. We talked last time about clearing the fraction, and you're welcome on this one to clear the fraction. However, I don't think it's necessarily worth the time for this one because my fraction is basically going to go away when I get rid of this -5/3 in front of my x squared. So x squared, again, is the only thing being squared. So I need to get rid of the -5/3. So I need to divide both sides by -5/3. So divide, and I'm writing it like this for a reason, -5/3. I wrote this one over here like this for a reason, I promise. So over here, the -5/3 will divide each other out, and I'm just left with x squared. Over here, if you guys will remember, when you're dividing with fractions, instead of dividing by the fraction, you're going to multiply by its reciprocal. So keep the first fraction the same, change it to multiplication, flip it, flip the second fraction over. Okay, so now we can clean that up a little bit. When you're multiplying fractions, it's straight across. So 1 times 3 and 5 times -5. So 1 times 3 just gives me 3. 5 times -5 is -25. So what I have is x squared equals 3/25. You can put the negative on top or on bottom or out in front. I tend to just put my negative on the top when the fraction is negative. I just put the negative on the top. So now that our square is isolated, we're going to take the square root. So square root here, square root here. Over here, the square and the square root cancel each other out, and I'm just left with x equals, got to put our plus minus in front. And then this looks kind of icky, but it's really not too bad. I want you to actually give the numerator and the denominator its own square root symbol. So we're going to do square root of -3 over square root of 25. Still have our plus minus. The square root of -3 is equal to the square root of -1 times 3. And then we have our square root of 25 on the bottom. Hopefully we can do that one without having to break it down. On the top, -1 becomes I. And then the square root of 3 is prime, so it's not going to simplify down. So it just is left as a square root of 3. And then on the bottom, the square root of 25 is 5. Sorry, I still need to put my plus minus in front. And that's your final answer for that one. So maybe a little work with fractions thrown into it, but hopefully that wasn't too terribly awful. Kind of all sort of made sense.